A z-score table, or the standard normal table, is a two-part table. It has the negative part and the positive part. It lists the z-score with the corresponding probabilities, but only the probabilities on the left-hand side of a certain z-score. The z-score is read from the first column and the first row. So for example, a z-score of negative 2.74 would be found from, first we go to the first column and find negative 2.7 only, because in the first column we only have one decimal place, but negative 2.74 is two decimal places. And so again, we first go to the first column and find negative 2.7. To complete this, we would go to the first row and find 0.4. 4 is in the hundredth place. It is found in the first row. And 0.04 together with negative 2.7 will give us a z-score of negative 2.74. The table only gives us the area on the left-hand side of the corresponding z-score. From the table, this area is also the probability. And so in this case, if z is negative 2.74, then the corresponding four-digit number inside the table would give us the area of this shaded region here, which is 0.0023. Let's find another z-score. If the z-score this time, a different z-score, is negative 2.4, which is negative 2.40, then we will do the same thing. We first go to the first column and locate negative 2.4. 0 is in the hundredth place, and to find it, we would need to go to the first row, and that is 0.00. The area on the left-hand side of the z-score is therefore 0.0082, and it is also the probability. And so again, the table, the standard normal table, only gives us the probability on the left-hand side of the z-score. And it only works if these are the z-score. The table is for the standard normal distribution only, with the mean of 0 and the standard deviations of 1. What about a positive z-score? It is the same thing. If we want to find the area on the left-hand side of a z-score, that is 1.96 for example, we would do the same thing. First, we locate 1.9, which is in the first column. And so we go to the first column and find 1.9. There it is. And then to get 1.96, we would go to the first row and locate 0.06. Together, this will give us a z-score of 1.96. The corresponding four-digit number is 0.9750. What this means is that if the z-score is 1.96, the area on the left of it would be 0.9750. It is the four-digit number that we located here, 0.9750, and that is the probability on the left-hand side of this z-score. And again, this is very important. The table only gives us the area on the left-hand side of the z-score. What happens if we want to find the area on the right-hand side of any given z-score? We would need to first find the area on the left, like we did earlier. To get the area on the right-hand side, we simply take 1 minus 0.9750 for the z-score of 1.96, and this will give us 0.0250. And this is because the area under the density curve is 1. And that is why we can take 1 minus the left to get the right. Very important. We cannot get the area on the right hand side right away from the table. And lastly, what happens if we have two z-scores and we want to have the area or the probability in between? Let's just say one z-score is 1.80 and another z-score is 2.32. And so we're looking for the probability between the two z-score. Remember that the table only gives us the area on the left hand side of the z-score. And so we first need to find the corresponding area for each of these z-score. One on the left, all the way from the left up to 2.32, and another all the way from the left up to 1.8. And so if we take the yellow area minus the green area, we would get the blue area. And so we would need to look up twice. For each z-score, we would need to look up the corresponding probability. 1.8 is 1.80. The corresponding probability is 0.9641. And so the green area is 0.9641. How about the yellow area? It is the area on the left hand side of 2.32. So first we would need to find 2.32. We first locate 2.3 in the first column and 32. So we would go to the first row and go to the 100th place with the digit 2. The corresponding probability is 0.9898. And so the area in yellow is 0.9898. And again, the yellow probability or area minus the green probability will give us the probability in green, which is the answer we're looking for, the area or the probability between 1.8 and 2.32. And if we take 0.9898 minus 0.9641, we will get 0.0257. And again, this is the probability between 1.8 and 2.32 z-scores.